Hello viewers, welcome to Emmanuel Maths Academy. So in the previous videos, we looked at various techniques and method of differentiation, right? Today we'll be looking at another method or another technique of differentiation, which is called the first principle method of differentiation. You can say the differentiation using the first principle, right? Now, for first principle method of differentiation, you see that given y equal to f of x, then the y dx here is the change in y with respect to what? X, which is equal to what? F prime of x is equal to limit as the delta s tends to 0, f of x plus delta x minus f of x all over delta x. This delta s simply means the change in x. You can call it delta s or change in x. As simple as that. Recall that in the previous general method of differentiation, the power rule, when you are given y equal to s power 2, right? To differentiate this, you have that your dy dx is equal to, this will multiply this, you have 2 times x 2 minus 1, which is equal to what? 2x, right? Then if you're using this method, for this method, which is the first principle method, using this definition, first of all, what we do here is what? We said that y is equal to x squared. What's the first thing you do? You have that f prime of x is equal to x plus delta x power 2 minus x power 2, right? All over delta x. From this definition, right? Because this is equal to f of x. Do you get the point? This is equal to f of x. So you are substituting this in terms of what we have in this definition, right? Then you break this thing down, you expand. You have f prime of x equal to x squared plus 2x dx plus delta x power 2 minus x squared all over delta x, right? Now, this is equal to f prime of x equal to x squared will cancel x squared. You now have 2x delta x plus delta x power 2. At this point, you can separate this to give delta x over delta x. Is that clear? So delta s will cancel delta s. Then one delta s here will cancel one delta s. You'll be left with what? 2x plus delta x. Then at this point, introduce your limit. The limit from delta s tends to 0, right? This is equal to f prime of x equal to limit delta x tends to 0, 2x plus delta x. That means substituting the value of, substituting 0 whenever you see the x. Now this will be what? Z plus 0. This will be equal to what? 2x. As simple as that. You can see that we got the same thing when we did our differentiation using the general method. Is that correct? Let's solve another example using this for proper understanding. Now let's say you are given another example. Let's say example 2. Example 2. Given that y is equal to s power 2 plus 2x. Is that correct? Now solution. So f prime of x is equal to limit of delta x tends to 0, x plus delta x power 2 plus 2x plus delta x minus x squared plus 2x all over delta x. By this definition here, you have that this will be subtracting this because this is your f of x. Now the change in this particular y minus f of x, that means the f of x plus change in x minus f of x. Is that clear? You now break this thing further to give you f prime of x equal to limit of delta x tends to 0. X squared plus 2x delta x plus 2x plus 2 delta x minus x squared minus 2x all over what? Delta x. Is that clear? Is that clear? So at this point, we have s square here, we have minus s square here. This will cancel this, right? But again, we have 2x here, we have minus 2x here, it will cancel also. Then what we have left is what? F prime of x equal to limit as delta x tends to 0. You have 2x delta x plus 2 delta x, right? Now separate this. You have this over delta x, this over delta x. Delta s will cancel delta s. Delta s will cancel delta s. You now have that this is f prime of x is equal to what? 2x plus 2. As simple as that. You can see that from this, you can, if you use the general method of differentiation, which is the power rule, you have that your what? The y, the x, which is f of x is equal to what? 2x 2 minus 1 plus 2x 1 minus 1, right? This is equal to 2x plus 2x over 0, it's equal to 2x plus 2. As simple as that. This is using the general method.